So this next section is called hypothesis testing, and what I want to assure you of is that in what we're doing, we're going to be doing the exact same calculations. However, we're going to use our calculations to answer a different question. So, in a sense, our first step will look different, our last step will look different, but everything in the middle, all the hard stuff that we've been doing, that we really already know how to do, that's all going to be exactly the same. All right. So I want to extend this question that we were just working on a second ago. So remember the cholesterol question where we said the population has a cholesterol proportion of 0.17, and we're talking about in our sample p hat is less than 0.12. So what's the probability of that happening? We answered that question. So in order to get us to our next topic, here's what I want to say. We talked about doing these calculations when we know the population mean and we know the standard deviation. And we just saw how to do is to do these calculations for proportion questions where we know the population proportion. This begs the question, why would we take a sample? If we already know these things, then why are we taking a sample? Simply to amuse ourselves?
Test the hypothesis.
Exactly. And that's it. And this is how we're going to look at it. So, we're going to flip our perspective. We will take a guess about the population mean or proportion and then consider it given the results of the sample. So, just to give you some think about this, for example. What if our sample had 0.02 high cholesterol? Would it then seem reasonable that the whole population has 0.17, has a proportion of 0.17 high cholesterol? Would that seem reasonable? No, something's got to give. Okay. In fact, we can actually do this we know how to do this calculation. So, P equals 0.17, N equals 80 and sigma P hat is 0.0420. This is all from before. So, what's the probability that P hat from my sample is less than 0.02? Let's do this calculation. How do we do this? So what do we need to mark off? So 0.17 goes where? In the middle, and that's a value for what? P hat. And what else do we mark off? And then what do we do? Shade to the left because it's less than. Okay, now what? Find the z-score. Okay, so z equals what? 0.02 minus 0.17 over. Right. And let's go ahead and find that. It's negative 0.15 over 0.0422. That gives us negative 3.5714. So let's fill that in. So now what do? Can norm S dist on that of negative 3.5714. what do we get? 0.0002.
That's a question mark, right?
Oh yeah. Okay. So when we do a hypothesis test, what we're going to do is we're going to go back and say, hey, was P equals 0.17 correct? So what do you think? Does P equals 0.17, if we don't know it to be a fact somehow, does that seem reasonable, or does that seem like a good guess? No, why not? What did we get in our sample? We got, what proportion did we get in our sample? We got 2%, which is 0.02. Now, how likely is it that the population proportion is 0.17, but my sample proportion is 0.02? How likely is that? It's not likely. In fact, how not likely is it? It's 0.0002 likely, which is very, very unlikely. Does that make sense? Okay. So what is the, when I say likely, what I really mean is probability. What's the probability that we have population proportion P 0.17, but sample proportion P hat 0.02? What's that probability? It's 0.0002. That's pretty small. Well, this is what it tells you. It says what is the probability or likelihood of getting a sample where this happens? It's 0.0002. That's the probability. So yeah.
So you would say it's not likely because 0.002 is less than 0.17?
No. We have a way of figuring out the probability of these things. So what's the probability that that was our sample proportion? Yeah. Is that a good probability or an unlikely probability? It's incredibly unlikely. So what we're going to do in hypothesis testing, what we're going to do is we're going to go back and say, and again, I'm being vague before I give you the formal language. Informally, what we're going to go back and say is 0.17 was not a good guess.
But that's because it's very small, right?
Right. So, do you understand this idea? Okay. Does this side of the room understand that idea? Okay. So that's the idea. And now we're going to go through hypothesis testing with the formal notation and language. All right. So how do you...
What is the answer when we find the area of the probability? What is the...
That's what we're going to do right now. That's what we're going to talk about right now. All right. Okay, so how do you do a hypothesis test? Step 1, a claim is made. Step 2, you get data from the sample. Step 3, you assess the plausibility of the claim. And let me also say that hypothesis and claim mean the same thing. So I'll use them interchangeably. All right. So what is a claim in hypothesis testing? And just going forward, for now, for a while, we're going to stick to making claims about the mean mu or the proportion p. there are lots of different sorts of claims you can make, and we'll get to that later. So for now, we'll just assume we're talking about mu or p. All right. So one sort of claim, you can say that p equals a certain value, like we just did. I think that 17% of Americans have high cholesterol. That's a claim. You can also say for mu equals a value. The average income in the U.S. is $40,000. And you write that as mu equals 40,000, of course. So you can make another sort of claim. You can also claim that mu is greater than some sort of value. The average basketball player is over 76 inches. How do you write that down? Mu is greater than 76. Alright. So once we make this claim, consider the claim mu equals 40,000. If that claim is wrong, then what's the case, or what's the opposite of that? What's the opposite of mu being equal to 40,000? Yeah, the opposite is mu is not equal to 40,000. So the way we're going to set up a hypothesis test is we're going to write down our claim and then what's called or hypothesis, and then we're going to write down the opposite, which is the alternate hypothesis. Okay. So as you should be able to infer from this, there are three different sorts of hypothesis tests. And for writing these out, I'm going to use mu. Again, as you know, you can also use p. Here we go. So the first way to write down a claim is we could say mu equals 40,000, and the opposite of that would be mu is not equal to 40,000. Now I wrote down HO and H1. What do you think H stands for? Hypothesis. That's it. The 0 and 1 are just so we know which is which. All right. Okay. Well, we're gonna keep coming back to this. We're gonna talk about this for quite some time in this class. Okay. So another way to make a claim is to talk about it being greater. So in the second case, the H1, which is called your alternate hypothesis, is mu is greater than 50. And in the third case, the alternate claim is that mu is less than 250. So these are three kinds of claims you can make: not equal, greater than, and less than. So I'll usually call them HO and H1, but if you want to describe them in words, HO is called the null hypothesis, and H1 is called the alternate hypothesis. HO, H1 is fine. I made it up.
Oh, okay. Oh, these just made up.
These are made up numbers. Right. Question? Was someone was asking a question? No. Okay. All right. So I just want to make a statement about notation. There's a convention. If you look at the first way of writing hypothesis, equals, not equals, those are clearly opposites. In the second case, greater than or equals, those are not opposites. It's a convention that we write it like this. Why? Long story short, when you start doing these problems, it's actually much easier just to remember that HO is, you always write down equals. It actually, hopefully you'll see as we do problems, that it's much easier to just remember that HO is always equals, as opposed to, like the last one, well, since this is mu is less than 250, then H1 is going to be mu is greater than or equal to 250. Because this greater than looks a whole lot like this greater than. And we don't want to confuse these at all. So for these reasons, technically we're not going to use opposites. We're just going to say HO is always equals, and then really H1 really determines what sort of which of these hypothesis tests we're doing. Alright. So that's a little convention. Hopefully you can get used to it. Okay. Now, what does the picture for each of these look like? Well, let's work from right to left. When mu is less than, where do you think you're going to shade? To the left. And in the middle one, mu is greater than, where do you think you're going to shade? To the right. So the only tricky bit comes with the first case, not equals. With not equals, where do you think you're going to shade? Well, not equals is the same as saying it could be greater than or it could be less than. So where do you, not everything. You shade the tails. Right. So again, think of if it equals, it's going to be in the middle. Think of it that way. So if it's not equals, it's either going to be greater than, which is to the right, or less than, which is to the left. All right. So again, I don't expect you to have all this stuff on the spot. You're going to pick it up as we do problems.